For the network shown below, v1 of t is equal to e power minus t for t greater than or equal to 0 and is 0 for all t less than 0. If capacitor is initially uncharged, determine the value of d square v by dt square and d cube v by dt cube at t equal to 0 plus. This is the given circuit. We are supposed to find v2 of t, its first derivative and its third derivative at t equal to 0 plus. It is said that the capacitor is initially uncharged. It means at t equal to 0 minus, Vc of 0 minus, that is charge in the capacitor, is 0, and we know that the capacitor immediately after closing the switch will be same as before closing the switch. That is Vc of 0 plus is same as Vc of 0 minus. Now we'll try to find d square v by dt square and its third derivative. So this is the given circuit. So this is V2 of t. It means the voltage at this point is also V2 of t and the voltage at this point is also V2 of t. We'll assume that the current through this branch is, say, I1. Current through this branch is, say, I2, and current through this branch is, say, I3. So this is the circuit when t is greater than or equal to 0 plus. That is, when t is greater than or equal to 0 plus, this is the circuit. Now we'll try to analyze this circuit. So applying KCL to above circuit, at node V2 of t. So here apply KCL at this node. So we can write I1 is equal to I2 plus I3. So I1 is nothing but V1 of t minus V2 of t divided by 10 ohm resistor is equal to I2 of t is V2 of t divided by 20, that is I is equal to V by R plus I, and the current through capacitor is given by C dV2 of t by dt, or I can write it as, so here V1 of t value is given, that is e power minus t, that is given in the problem itself, that is V1 of t is e power minus t. So let me substitute that, e power minus t minus V2 of t divided by 10 minus 1 over 20. I'll take these two terms on left hand side. V2 of t minus so here C value is 1 by 20, that is 1 by 20 dV2 of t by dt. We'll call it as equation 1. Now at t equal to 0 plus, equation 1 can be written as, so consider t equal to 0 plus, so it will become e power 0, that is e power minus 0, and we have V2 of t, that is minus V2 of 0 plus divided by, we have 10 minus, we have V2 of 0 plus, because we have considered t equal to 0 plus. Wherever there is t, we have to replace it by 0 plus. V2 of 0 plus divided by 20 minus 1 over 20. We have dV2 of t by dt, that is dV2 of 0 plus by dt is equal to 0. So here V2 of 0 plus value is 0. Here V2 of 0 plus is equal to 0, because initially capacitor is uncharged. Capacitor voltage itself is V2 of 0 plus, which is 0. So therefore, so here e power minus 0 is 1 minus V2 of 0 plus is 0 divided by 10 minus, we have V2 of 0 plus, this term is 0, minus 1 by 20 d by dt V2 of 0 plus is equal to 0. So therefore we can write 1 by 20 d by dt V2 of 0 plus is equal to 1 by 10. So therefore d by dt V2 of 0 plus is equal to 2 volts per second. But in the problem we need d square V of by dt square. Now let me, to get d square V by dt square, we supposed to differentiate this equation. Differentiate equation 1. So here the differentiation of e power minus t is minus e power minus t. That is, let me take 1 by 10 as common, minus e power minus t. Then we have differentiation of this V2 of t is d by dt V2 of t, that is minus d by dt V2 of t. Then we have 1 by 20 dV2 of t by dt minus 1 over 20 dV2 of t by dt. Then we have 1 by 20 d square V2 of t by dt square is equal to 0. I will call it as equation 2. So now at t equal to 0 plus, so wherever there is t, replace t by 0 plus. So I can represent it as 1 over 10 minus e power 0 minus d by dt V2 of 0 plus minus 1 over 20 d by dt V2 of 0 plus minus 1 over 20 d square V2 of 0 plus by dt square is equal to 0. Simplifying this further, 1 over 10, so its value is e power, sorry, this is minus e power 0 is 1, that is minus 1 minus d by dt V2 of 0 plus. So already we found d by dt V2 of 0 plus, that is 2 second, that is 2 minus 1 over 20, this is 2 minus 1 over 20, we have d square V2 of 0 plus by dt square is equal to 0. So now simplifying this, this will be minus 3 by 10 minus 1 by 10 is equal to 1 over 20 d square V2 of 0 plus by dt square. So simplifying this, I can get, I'll send this 20 on other side, will get d square V2 of 0 plus by dt square is equal to, this is 20 by 10 is 2, this is minus 6 minus 2, which is equal to minus 8 volt per second square. So this is the second derivative of voltage V2 of 0 plus, and its answer is minus 8 volts per second square. So now we are supposed to calculate third derivative of voltage. So now here in equation 2 we have second derivative of voltage. If we differentiate this equation, we will get third derivative of voltage. Let me differentiate equation number 2, that is differentiate equation 2. So we get 1 by 10. We have e power minus t minus d square v2 of t by dt square. Then we have minus 1 by 20 d square v2 of t by dt square. Then we have minus 1 by 20. This will become differentiation of this will be d cube v2 of t by dt square is equal to 0. So now at t equal to 0 plus, substitute t equal to 0 plus here, 1 over 10 e power 0 minus d square v2 of 0 plus by dt square minus 1 over 20 d square v2 of 0 plus d square v2 of 0 plus by dt square minus 1 over 20. We have d cube v2 of 0 plus by dt cube is equal to 0. Now substitute the values. 1 over 10, its value is 1, minus d square v2 of 0 plus by dt square, already we have found, that is minus 8 second. So minus minus it will be plus 8 minus 1 over 20. Here it is minus 8 minus 1 over 20. We have d cube v2 of 0 plus by dt cube is equal to 0. So simplifying this is 9 by 10 plus we have 8 by 20 is equal to 1 over 20 d cube v2 of 0 plus by dt cube. So simplifying this, take 20 on other side, it will become, if you take 20 this side, it will become 20 by 10 is 2, 2 into 9 is 18, plus here it will be 8 is equal to d cube v2 of 0 plus by dt cube. That is, simplifying this, will get d cube v2 of 0 plus by dt cube is equal to 28 volts per second cube. So this is the third derivative of v2 of 0 plus. Thank you for watching.